Problem 5. So in this problem, we're asked how much energy is required to melt a 30-gram ice block. And we're told that the latent heat of fusion of the ice is 3.33 times 10 to the 5 joules per kilogram. So in order to work out the energy required to melt the ice, we can use Q is equal to ml. The mass of the ice is 30 grams, so this is 30 times 10 to the minus 3 kilograms times the latent heat of fusion, which is 3.33 times 10 to the 5 joules per kilogram. So solving this on the calculator, we get 9,990 joules, which we should give our answer to two significant figures, as the 30 grams is given to two significant figures, so this is equal to 10,000 joules. Now the question goes on, if this ice block was placed in a 200 milliliter glass of water, okay, so let's draw that. Here's our glass of water, here's our ice block, and this is 200 milliliters, which remember is equal to 200 grams of water. And we're told that the initial temperature of the water is 27 degrees C, and we're told after the ice is melted, what is the temperature of the water, and we're told that we can assume that there's no energy exchange between the surroundings. So that tells us that the total energy change is equal to 0. And so 0 is equal to the energy given to the ice to melt it. Now once the ice is melted, it's then melted ice at 0 degrees C, and so it needs more energy to raise its temperature up to whatever the final temperature is. So that amount of energy is equal to the final temperature minus the initial temperature of the ice, which will be 0 degrees C. So this term here, combined, is equal to the energy gained by the ice, and that energy is lost by the water. So the water loses energy as its temperature decreases, and so the amount of energy lost by the water is given by the mass of the water times the specific heat of water times the change in temperature of the water, which is the final temperature minus the initial temperature of the water. So now what we can do is we can substitute in. We know that ml is 9,990 joules. We'll keep all the significant figures for the working and then present our final answer just to two significant figures. Plus we've got 30 grams of ice times, once it's melted, it's water, so this is 4,186, times the final temperature minus the initial temperature, which is 0. Plus the mass of the water, which is 0.200 kilograms because it's 200 grams, times 4,186 times the final temperature, which we're trying to find, minus the initial temperature. Now, in order to solve this, what we're going to do is we're going to move all the numerical terms over to the left-hand side and leave the terms with a TF on the right-hand side. So we'll move this one over, so we've got minus 9990, and now 0.2 times 4,186 times minus 27 gives us minus 22,604. So we move it over to the other side, it becomes a plus. 22,604 is equal to, and then we've got our terms with a TF in them. So 30 times 10 to the minus 3 times 4,186 plus 0.200 times 4,186, or times TF. And so we can rearrange this. TF is equal to this side, which is 12,614, over the term in this brackets, which when you put it into the calculator, you get 962.78. So solving this on the calculator, we get 13.1 degrees C, but we should give our answer to two significant figures, so that's 13 degrees C.